Today we begin a new lesson, section 7-1, finding areas of parallelograms and rhombuses. Let's start with the definition of area. Area is the amount of space inside the boundary of a flat, two-dimensional object, such as a triangle or a circle, or the surface of a 3D object. So today we're going to talk about the area, or that area, the space inside the boundary of a two-dimensional parallelogram and rhombus. Okay, up top at the key concept, it says you can decompose. Now this word decompose really means just to take apart. So you can decompose a parallelogram and then compose a rectangle to find the area of a parallelogram or a rhombus. So compose would be the opposite, which would be put together. So to understand the formulas and how they're really similar between a parallelogram and a rectangle, we're going to learn how you can decompose or take apart a parallelogram and then put it back together to compose it to form a rectangle. The formula for the area of a rectangle is length times width, and you can write the area formula for a parallelogram instead as base times height. So they are very similar, except for we're using the words length and width for rectangle, and we're using base and height for parallelogram. Okay, in this first example, you'll see a rectangle. This rectangle has a length of 6 and it has a width of 5. So the formula, and you always write the formula as you are completing each problem, okay? So you would write A equals L times W, and then we're going to replace the L with the actual length, okay, which is 6. And then we're going to replace the W with the 5 for the width of the rectangle, and then we multiply 6 times 5 and we get 30 feet squared. This little 2, superscripted 2, is just telling you how many dimensions. So we have a length and we have a width. That's 2 dimensions. If we were talking about volume, like a cube, that would have a 3rd dimension. It would have height in it. So then this would be a 3 here instead. So this is literally how many dimensions. Okay, so the next one, we have a rhombus here. Okay, actually it is a parallelogram because the length and the base and the height are different sizes. Okay, so this is a parallelogram. The formula is A equals the base times the height. So we're going to replace this B with the actual value for the base, and that's given as 6 feet. We're going to then replace the H, which is the height. The height on a parallelogram would be if you drop one of these corners from this vertice straight down, perpendicular to the base. You'll see it forms a right angle. That would be the height of your parallelogram, okay, and that is 5. Multiply the 2 together and you get 30. Now that was the same value we got here because our dimensions are the same. Okay, and now they're going to show you if you decompose, so it's like we're cutting, we're snipping this dashed line with a scissor, taking the triangle and flipping it and moving it to fill this space here. So we're kind of moving it from there, and instead we're placing it on this side, and what we would get if I darken sort of the outside part of it, we get the identical rectangle, and that's what they're showing you right there. Okay, so we're going to move to the Do You Understand section, and number 1 is always the essential question. It is our focus question for the lesson. I will say that this is a lengthy answer for this number 1. You're not going to want to write too big, and if you do, just find another space to continue, either another sheet of paper, or if you have some space at the bottom of your page here, you could draw an arrow, okay, to finish it. So I'm going to go ahead and give you a few moments to write down the information, and then we will go over it. Okay, so the answer says that a parallelogram can be decomposed into a triangle and a trapezoid, which we saw up here. So we took the parallelogram and we sort of cut off this triangle. We were left with this other shaded area, okay, which is a trapezoid. And we moved the triangle, kind of flipped it to rearrange it. And right here, to finish this, we could compose it into a rectangle. The length, which is L of the rectangle, is now the B base, or was the base of the parallelogram. And the width of the rectangle is or was the height of the parallelogram. So we're just interchanging some letters here. So instead of using length, we call it base, but it's still like the length. And then the width, which runs vertically, we now call the height, depending on the image. So this is our rectangle formula. This is our parallelogram or rhombus formula. Okay, number 2. Ken combined a triangle and a trapezoid to make a parallelogram. If the area of the triangle is 12 inches and the area of the trapezoid is 24 inches, what is the area of the parallelogram? Okay, so if we go back up here, we had our parallelogram, which was shaded in gray, okay? If the triangle, this area here, all that space shaded in for the triangle, okay, if that was 12 inches squared, and then this trapezoid, this other gray shaded area, had a value of 24 inches squared, what would be the total? Well, when you're asked for a total, you're just simply adding the two together. So 12 plus 24 gives you 36. So again, the answer is 36, and that's because we're adding the areas of the triangle and the trapezoid, and that gives us the total area of the parallelogram. Okay, moving to question number 3. It says critique reasoning. A parallelogram is 3 meters long and 7 meters high. Liam said that the parallelogram's area is greater than the area of a rectangle with the same dimensions. Go ahead and underline that. So the parallelogram base is 3 meters. So if we're comparing it to the rectangle's length would be 3 meters. And the parallelogram also has a height of 7 meters, which would correspond in a rectangle to the width. The width would be 7 in the rectangle. So the answer would be no. The areas of a parallelogram and a rectangle with the same dimensions are equal. And that just takes us, and I'll go back to that answer, but that takes us back, if we look at these original before what I added here, okay, my rectangle. This rectangle was a 6 by 5, and this parallelogram was also a 6 by 5. Okay, you're just multiplying the two together, and you get the same area, that 30 feet squared. So in this case, you have a 3 by 7. 3 times 7 is 21. It doesn't matter if it's a rectangle or a parallelogram, it will be the same. Okay, moving to the examples, and these will go pretty quickly. Now, these are all parallelograms. You know that they're not rhombuses because the rhombus would have the same base and the same height. So because we have different dimensions for all 3 of these examples, okay, all 3 are parallelograms. And the formula for a parallelogram is area, A for area, equals B for base times height. When you have 2 letters side by side without any symbol in between, that is representing multiplication. If I needed to add them, I would put a plus sign. If I was going to subtract them, I would put a minus. If I was dividing, I would have a fraction bar. When you don't see any symbol and you have 2 letters side by side, it is multiplication. We're now going to replace the letters for the information I'm provided. So I am given the base here is 20. So we're going to replace that B with 20. And this height, now I'm going to replace it with 21.5, but let's look how weird that looks, right? It almost looks like 2021. So even though these letters are side by side, these numbers are side by side, but we are going to use a parenthesis to separate the 2 numbers so that I know that those are 2 distinct numbers that are multiplied together and not that the answer is 2021. All right, and then we're going to go ahead and multiply. So we'll have 20 times 21.5, and that gives me 430. So the area A is equal to 430, and it's inches, and this is 2-dimensional. It has a base and it has a height. So we're going to put a little 2 there. Okay, we'll do one more together, and then I'm going to have you try number 6 on your own. Okay, so again, this is a parallelogram, so it's not length times width, it's base times height. I'm going to replace the B for base with the number provided for the base. I'm going to replace my H with this 12.5. But again, these are two distinct numbers, not one long number, and I'm multiplying them together, so I'll use that parenthesis to separate the two numbers. Some teachers, some books will even put a second parenthesis so that you have a parenthesis around both numbers, but that is preference, okay? So just the way I've always done it, the way I learned it back in the day in school, we just, wrote the first number and the second number was separated with the parenthesis, but a lot of teachers and books do it this way as well. Okay, so now we're going to go ahead and multiply those together. So 16, oops, let me go back. 16 times 12.5, and I get exactly 200. So 200 centimeters squared, because it is only two-dimensional. All right, so go ahead, take a few moments, and do number 6. Make sure that your response is 3 steps. The first step, you write the formula. The second step, you plug in what you know. And the third step is completing that operation and having your final answer. Okay, begin. Okay, and hopefully for this one, you got 12 times 10 is 120. And don't forget your units, okay? It's meters squared. Okay, the last one involves a little bit of algebra, okay? So for this one, we're dealing with a rhombus, okay? And what you could do is, number one, know that a rhombus has the same measurements, okay? So your base and the height would be the same. So if it's telling us that the base is 22, we know that the height is also 22 because it's a rhombus. If it was a parallelogram, well then the sides would be very different. So we'll just show this how the algebra works with a rhombus, knowing right away what the answer is going to be so that hopefully the steps I show you make some sense because we arrive at the same answer. So we're going to write the formula. So area of a rhombus, which is a type of parallelogram, is base times height. I like to draw a line down my equal sign sometimes, especially when there's division involved, just to keep things nice and orderly. Now, they give me the area here. So they give me this number. Now, prior, in these other examples, they didn't give me the area at all. That's what I was solving for. So since it was unknown, I left the variable as the letter A. Here, I'm given what the value for the area is. I'm told what goes in A's place, and that's 440. So I'm just going to put that equal sign right on the line. And it tells me that the base is 22, but it doesn't tell me the height. So what you're being asked to do is identify what number here times 22 is equal to 440. Okay, so what we're going to do is, and let me see, okay, so we're going to divide both sides by 22, and actually they give us, so 22 divided by 22 is 1h, so our height is equal to, and then we're going to do 440 divided by 22. Oh, it actually gives me a height of 20. So what you do to one side, what I did to the right-hand side, I divided by 22. I also had to do to the left-hand side, dividing by 22. And I got a height of 20. Okay, so a rhombus has 4 equal sides. So this would not have 4 equal sides if the height is different. So I think this word should be parallelogram. Okay, so that would be a mistake by the book. Okay, because if it's a rhombus, all 4 sides would be the same. But if you have a height in a rhombus that's larger than the base, then you would have 2 pairs of sides that are different sizes, which would be a parallelogram. Okay, there will be in the practice that you'll do in the next step, there will be 1 or 2 questions like this where you're given the area and given either the base or the height, where you have to just divide really quick to find the missing dimension. All right, have a great day.